Namaste, Hamisha Kushro Vidya. My name is Manisha Singh. Today I am teaching you cleaning systems in dairy industry. First of all, what is the aspects of cleaning? The arrangement for cleaning equipment that comes in contact with products are an essential part of the food processing plant. It must be kept in mind that food manufacturers are always obliged to maintain high hygienic standards, and this applies both to the equipment and naturally to the staff involved in the production. This obligation can be considered under three headings, that is trade obligation, moral obligation, and legal obligation. For the trade obligation, good, wholesome, clean products that keep well and are free from health hazards are obviously good for trade. Customers will buy the same product again. However, if a product is contaminated, does not keep well, or is the subject of complaints to the authorities, the reverse is true and the resulting publicity is very damaging. The potential effects of poor cleaning, poor standards, and poor quality must be kept in mind at all the times. Then moral obligation. Most of the customers who consume the products never see the factory or how the products are handled. They trust the company, rely on its reputation, and take it for granted that operations are carried out under the cleanest conditions by the well-trained staff who are continuously aware and conscious of these factors. Then legal obligations. The law attempts to protect the customer and purchasers in respect of health and quality. Failure to meet the legal obligations, national or local, can result in a very severe action, and prosecution proceedings can be very costly. Prevention is better than cure, and companies are obliged to meet legal requirements and maintain high standards. Milk and milk products, by their nature, are ideal media for the growth of microorganisms, including the many pathogens. As a result of this, there is more legislation concerning milk, its production, handling, processing, packaging, storage, and distribution than any other food product. Each country has its own national and perhaps local legislation standards. Then, what are the cleaning objectives? Talking about the cleaning results, the following terms are used to define the degree of cleanliness. Physical cleanliness includes the removal of all the visible dirt from the surface. Chemical cleanliness includes removal not only of all the visible dirt but also microscopic residues that can be detected by taste or smell but are not visible by the naked eyes. Then bacteriological cleanliness includes attained by the disinfection, and sterile cleanliness, destruction of all the microorganisms. It is important to note that equipment can be bacteriologically clean without necessarily being physically or chemically clean. However, it is easier to achieve bacteriological cleanliness as a matter of routine if the surfaces in question are first rendered at least physically clean. In dairy cleaning operation, the objective is nearly always to achieve both chemical and bacteriological cleanliness. The equipment surfaces are therefore first thoroughly cleaned with chemical detergents and then disinfectant. It is important to note that equipments can be bacteriologically clean without necessarily being physically or chemically clean. Then dirt. What kind of dirt is it that is present on the surfaces of dairy equipment and needs to be removed? It consists of deposits stuck to a surface, and its composition in this particular case is based on milk components that are utilized by the bacteria hidden in the dirt. Then heated surfaces. When milk is heated above 60 degrees Celsius, milk fouling starts to form, and this is a deposit of calcium, phosphates, and proteins, fat, etc. And you can easily see the result on heat exchanger plates after a long production run in the heating section and the first part of the regeneration section to follow. The deposits stick tight to the surfaces, and after runs of more than 8 hours, a change of color from whitish to brownish can also be observed. Then cold surfaces, a film of milk adheres to the walls of pipelines, pumps, tanks, etc. When a system is emptied, cleaning should start as soon as possible, or otherwise this film will dry out and can be harder to remove. Then cleaning procedures. Cleaning of dairy equipment was formerly done by people armed with brushes and detergent solutions who had to dismantle equipment and enter tanks to get the surfaces. This was not only laborious but also ineffective. Products were often reinfected from imperfectly cleaned equipment. Circulatory CIP systems adapted to the various parts of the processing plant have been developed to achieve the good cleaning and sanitation results. Cleaning operation must be performed strictly according to the carefully worked out procedure in order to attain the required degree of cleanliness. This means that the sequence must be exactly the same every time. The cleaning cycle in a dairy comprises the following stages. That is the recovery of product residues by scraping, drainage and expulsion with water or compressed air, pre-rinsing with water to remove loose dirt, cleaning with detergent, rinsing with clean water, and disinfection by heating or with chemical agents. If this step is included, the cycle ends with the final rinse if the water quality is good. Each stage requires a certain length of time to achieve the acceptable result. Then recovery of the product residues. All the product residues should be recovered from the production line at the end of the run. This is important because of the three reasons. That is minimize the product losses, facilitate cleaning, and reduce the load on the sewage system, which often means a considerable saving in a sewage treatment costs. Time must be allowed for the product to drain from tank walls and pipes. Surfaces coated with solid residues, for example, butter. In butter, printing machines must be scraped clean. Before cleaning starts, the remaining milk is forced out of the production lines with water. Wherever possible, the milk is piping in the piping systems is blown or flushed with the water to the collecting tanks. Then pre-rinsing with water. Pre-rinsing should always be carried out immediately after the production run. Otherwise, the milk residues will dry and stick to the surface, making them harder to clean. Milk fat residues are more easily flushed out if the pre-rinsing water is warm, but the temperature should not exceed 55 degrees Celsius to avoid the coagulation of proteins. Pre-rinsing must continue until the water leaving the system is clear, as any loose dirt left will increase detergent consumption. If there are dried milk residues on the surfaces, it may be an advantage to soak the equipment. Soaking softens the dirt and makes cleaning more efficient. The mixture of water and milk from the initial pre-rinsing can be collected in a tank for special processing. Cleaning with dirt. The dirt on sorry Cleaning with detergent. The dirt on heated surfaces is normally washed off with alkaline and acid detergents in that order on or the reverse order with intermediate water flushing, whereas cold surfaces are normally cleaned with alkalis and only occasionally with an acid solution. To obtain good contact between the alkaline detergent solution, typically caustic soda, and the film of dirt, it may be necessary to add a wetting agent which lowers the surface tension of the liquid, and the detergent must also be capable of dispersing dirt, encapsulating the suspended particles to prevent flocculation. Polyphosphates are effective emulsifying and dispersing agents that also soften water. The most commonly used are sodium triphosphate and complex phosphate compounds. A number of variables must be carefully controlled to ensure satisfactory results with a given detergent solution. These are the concentration of the detergent solution, temperature of the detergent solution, mechanical effect on the cleaned surfaces, that is velocity, and duration of the cleaning. First is detergent concentration. The amount of detergent in the solution must be adjusted to the correct concentration before cleaning starts. During cleaning, the solution is diluted with rinsing water and milk residues. Some neutralization also takes place, and it is therefore necessary to check the concentration during cleaning. Failure to do this can seriously affect the result. Checking can be done either manually or automatically. The dosage must always be according to the detergent supplier's instructions, as increasing the concentration does not necessarily improve the cleaning effect, and it may indeed have the reverse effect due to the foaming, etc. Using too much detergent simply makes cleaning needlessly expensive. As a thumb rule, cleaning with alkaline detergent should be done at the same temperature as the product has been exposed to, but at least 70 degrees Celsius. Then the temperature of the detergent. Generally speaking, the effectiveness of the detergent increases with increasing the temperature. A blended detergent always has an optimum temperature that should be used. As a result, as a rule of thumb, cleaning with alkaline detergent should be done at the same temperature as the product has been exposed to, but at least 70 degrees Celsius. Temperature of 68 to 70 degrees Celsius are recommended for cleaning with acid detergents. Then mechanical cleaning effect. In manual cleaning, scrubbing brushes are used to produce the required mechanical scoring effect. In mechanized cleaning of pipe systems, tanks and other process equipment, the mechanical effect is supplied by the flow velocity. The detergent feed pumps are dimensioned for higher capacities than the product pumps with flow velocities of 1.5 to 3 meter per second in the pipes. At these velocities, the liquid flow is very turbulent and this results in a very good scoring effect on the surfaces of the equipment. Next is duration of the cleaning. The duration of detergent cleaning phase must be carefully calculated to obtain the optimum cleaning effect. At the same time, the cost of electricity, heating water, and labor must be taken into the consideration. It is not sufficient to flush a pipe system with a detergent solution. The detergent must circulate long enough to dissolve the dirt. The time this takes depends on the thickness of the deposits, and heat exchangers encrusted with coagulated protein must be exposed to circulating an alkaline detergent followed by an acid solution for in total 20 to 60 minutes, whereas 10 minutes treatment with alkaline solution is enough to dissolve the film on the walls of a milk tank. Next is rinsing with clean water. After cleaning with detergent, the surfaces must be flushed with water long enough to remove all traces of the detergent. Any detergent left in the system after cleaning can contaminate the milk. All parts of the system must be thoroughly drained after rinsing. Softened water is preferred for rinsing, and this prevents deposition of lime scale on the cleaned surfaces. Hard water with a high content of calcium salts must therefore be softened in ion exchange filters to 2 to 4 DH, that is the German degrees of hardness, and the equipment and pipe systems are practically sterile after the treatment with strong alkaline and acid solutions at a high temperature. It is then necessary to prevent overnight growth of bacteria in the residual rinsing water in the system, and this can be done by acidifying the final rinse water to a pH of less than 5 by adding phosphoric or citric acid. This acid environment prevents the growth of the most bacteria. Then disinfection. Properly carried out cleaning with acid and alkaline detergents render the equipment not only physically and chemically but also to large extent bacteriologically clean. The bacteriological cleaning effect can be further improved by disinfection. This leaves the equipment virtually free from bacteria. For certain products, it is necessary to sterilize the equipment to render the surfaces completely free from bacteria. Dairy equipment can be disinfected in the following ways: thermal disinfection and chemical disinfection. Thermal disinfection includes the boiling water, hot water, and steam, and chemical disinfection includes the chlorine, acids, iodophores, hydrogen peroxide, etc. Disinfection can be done in the morning immediately before milk processing begins, and the milk can be admitted as soon as all the disinfectant has been drained from the system. If disinfection takes place at the end of the day, the disinfection solution should be flushed out with water to avoid leaving any residues that may attack the metal surfaces. Then CIP, that is clean in place systems. CIP means that rinsing water and detergent solutions are circulated through tank, pipes, and process lines without the equipment having to be dismantled. CIP can be defined as circulation of cleaning liquids through machines and other equipment in a cleaning circuit. The passage of high velocity flow of the liquids over the equipment surfaces generates a mechanical scoring effect that dislodges the dirt deposits. This only applies to the flow in pipes, heat exchangers, pumps, valves, separators, etc. The normal technique for cleaning large tanks is to spray the detergent on the upper surfaces and then allow it to run down the walls. The mechanical scoring effect is then often insufficient, but the effect can to be some extent be improved by the use of specially designed cleaning devices. Tank cleaning requires large volume of detergent which must be circulated rapidly. The CIP programs, dairy CIP programs differ according to whether the circuit to be cleaned contains heated surfaces or not. We distinguish between the CIP programs for circuits with pasteurizers and other equipments with heated surfaces, that is UST, etc., and CIP programs for circuits with pipe systems, tanks, and other process equipment with no heated surfaces. The main difference between the two types is that acid circulation must always be included in the first type to remove encrusted protein and salts from the surfaces of the heat treatment equipment. A CIP program for a pasteurizer, hot components, circuit can consist of the following stages. First is rinsing with warm water for about 10 minutes, then circulation of an alkaline detergent solution for about 30 minutes at 75 degrees Celsius, rinsing out alkaline detergent with warm water for about 5 minutes, circulation of nitric acid solution that is 0.5 to 1.5% for about 20 minutes at 70 degrees Celsius, post rinsing with cold water, then gradual cooling with cold water for about 8 minutes. Then the pasteurizer is usually disinfected in the morning before production starts, and this is typically done by circulating hot water at 90 to 95 degrees Celsius for 10 to 15 minutes for returning temperature as is at least 85 degrees Celsius. A CIP program for a circuit with pipes, tanks, and other cold components can comprise the following stages. First is rinsing with cold water for 3 minutes, circulation of 0.5 to 1.5% alkaline detergents at 75 degrees Celsius for about 10 minutes, rinsing with warm water for about 3 minutes, disinfection with hot water 90 to 95 degrees Celsius for 5 minutes, then gradual cooling with cold tap water for about 10 minutes. That is normally no cooling for tanks. Then steps for CIP cleaning for cold components. This is followed by rinsing with water, circulation of alkaline detergent, then rinsing with hot water, disinfection with hot water, and then cooling with tap water. Hope you all are satisfied with this session. This session is powered by Digital Version 2.0 Jyoti Vidyapeeth Women's University, Jaipur. If you have any query, please mention it in a comment box. I will resolve them whenever we have a live session. Thank you so much for watching this.